Welcome to this eLearn Security video lesson on Linux Exploitation Remote Exploitation. In this video, we are going to cover a PHP CGI argument injection remote command execution vulnerability, which affects PHP versions 5.3.12 and 5.4.x before versions 5.4.2 and exploits a configuration where PHP is configured as a CGI script, also known as PHP-CGI or PHP 5-CGI in this particular case. The vulnerability allows for the passing of command line arguments to the PHP interpreter via a specially crafted URL, resulting in disabling several of PHP's protective directives, which are then processed on the server along with our PHP payload. This ultimately results in remote command execution and allows us to execute a command of our choosing. We will exploit this vulnerability to obtain a reverse netcat shell as the www-data user on the affected target. For this demonstration, the vulnerable PHP version we'll be using is 5.2.4, as can be seen in this PHP info output on the affected target web user. Now, to understand how this particular vulnerability works, let's take a look at our URL, which could be crafted to exploit it. First, we'll take a look at a proof of concept command using curl without any URL encoding applied so that we can break down each part. In the curl command breakdown, we can see we're passing a number of parameters to the PHP interpreter with the -d flag, which allows for the manipulation of values associated with the PHP configuration, many of which result in decreasing PHP security. In particular, the allow_URL_include, safe_mode, and the auto_prepend_file options. In addition to disabling several of the PHP directives, we're also including our payload as part of the -data-binary flag in the curl command. Now, in order to properly pass all of the above arguments through to the PHP interpreter as URL, we should first URL encode any special characters which appear in the above URL. In short, we'll want to replace the characters in the URL with their URL %encoded equivalents. For spaces, we'll use the plus character. For equal, we'll use %3d, and so forth, as can be seen in the following conversion chart for our proof of concept. Once we've URL encoded the values, we should end up with a curl command like the following. You can also see in the curl command that we're using a netcat reverse shell payload as part of the PHP data, which will be sent via a post request denoted by the -x parameter. Our next step before we send our curl command with our payload is to set up a netcat listener on our attacker machine. We'll do this on port 5555. Lastly, if all goes well, we should be able to issue our curl command and receive a reverse shell back to our attacker machine from the target system. Great! We've got a shell as the www-data user, as we can see with the output of the id command. In order to get a semi-interactive shell, let's first spawn a Python-based sudo terminal, similar to what we've used throughout the course. Notice that we have a shell as the www-data user, which is not a root user in this case. But let's see if we can find perhaps a SUID root executable we can use to elevate our privileged. One interesting SUID root executable should stick out to us, particularly the nmap command. Let's see if we can launch its interactive mode for a potential shell escape. Great! Interactive mode is available. Let's try and break out to a shell with the bang-sh command. We can see we have successfully escalated our privileges to root. For this next segment of Linux exploitation remote exploitation, we will cover the exploitation of a druby RMI server service version 1.8 using Metasploit for remote code execution. druby, or DRB, is a distributed object system written in the Ruby programming language and can be found listening on TCP port 8787. We can learn more about druby in the link displayed below. Version 1.8 of the druby RMI implementation is vulnerable to remote code execution due to the lack of what is known as taint checking, and is essentially a way that some program languages such as Perl, and Ruby in this instance, check to make sure data being received by the protocol is safe for processing. In this case, with this vulnerability, the druby server fails to properly check the data received when the data is passed to syscalls within the protocol. More details on the technical specifics of this vulnerability can be found at the link below. Now it should be noted that a typical Nmap scan for the top 1000 ports does not include port 8787, and so it becomes important that we conduct a comprehensive scan for all 65,535 ports, or include this port with our usual scans as part of our methodology. So, first, let's confirm that our target has port TCP 8787 open with an Nmap scan. Now that we've confirmed the port is in fact open, let's see if we can get a fingerprint from the service and confirm that it is a druby RMI server listening using an Nmap version scan with the -sv switch. As we can see from the Nmap version scan results, we've identified that Ruby DRB RMI is running on our target host. Now for this exploit, we can use a module included within the Metasploit framework. Executing a search query using the string DRB returns several results. But the one we'll want to use is the drb_remote_codeexec module. Let's load with the use exploit/linux/misc/drb_remote_codeexec command. Once we've loaded the module and run the show options command, we can see that we only need to modify our target host rhost value, since our target port is listening on its default of TCP 8787. We can also leave the URI value to its default setting of no, as Metasploit will be able to identify the correct URI for our target in most cases. Once our module is configured, we can either type run or exploit to launch the exploit. If our target is vulnerable, we should then be presented with a shell session and can start interacting with our target host. Depending on the user that the service is running under, we may need to escalate our privileges at this point. However, running the id command, we can see that we are root in this instance. From here, we can then use our python sudo tty command to upgrade our shell and continue on to post-exploitation tasks, such as persistence, maintaining access, and moving laterally within our target environment. And this concludes our video lesson on Linux exploitation remote exploitation. Thank you for joining us.